When I hear people around saying, "Oh, we don't need packaging," so pay attention because packaging as a function is protecting food and avoiding waste of food. And wasting food is one of the big problems, especially when the world population is going to target 10 billion people. So food is going to be a problem. So every action has to be devoted to save it.
That was from this episode. And I'm sure when you listen through the entire conversation, you'll appreciate the argument of why it is important to look at options for recycling and upcycling plastics and other polymers. Hello and a warm welcome to yet another episode on the Mission Shunya podcast. Welcome back. This is episode 76, and as we have crossed 75, it is time to look at the next phase of this channel. Well, I can't help but review my work from time to time and see how it's going, just to ensure that I deliver the content in its best form and which equips you with all that you need to be a part of this transition to the net zero carbon economy. Which goes back to the name of the podcast, Mission Shunya, aka Mission Zero. As part of the review process, you are always welcome to send in your opinion, feedback. missionchunya@gmail.com is the ID. Or you can find me on social media across platforms. The handle is @missionchunya. One big shift in recent weeks is the podcast artwork, which is now courtesy of friendly support from terrageneration.com, a content agency specialized in telling stories in climate, biodiversity, and sustainability. As part of the next phase, which is going to be all about amplification of the work and the message, I have a new newsletter that is coming up. So stay tuned for all updates on that. Now on to the feature segment of this week. As consumers, we are all aware of the waste trail that we leave behind as part of our consumption, be it materials, plastic, and even for that matter, food. Every bit of it, when wasted, is a drain on our resources, because it took a lot of resources to produce it in the first place, which then goes back to the carbon intensity of consumption or carbon emissions associated with production. We definitely can't switch to alternatives in one go, but we can definitely ensure we have the technology backup to enable us to have that switch. This week, we have a materials scientist whose hard work over the years has resulted in a breakthrough and is now on the road to commercialization. So, who is our guest for today?
Hi, my name is Maurizio Crippa, and I am CEO and founder of Gr3n. My background is I'm a material scientist, and then I invented with my friends this technology to recycle PET many years ago, and now we are really keen and focused to solve this problem, this environmental problem about PET recycling and CO2 impact. I'm an enthusiastic person, and I'm very positive that we can solve the problem of CO2 into the atmosphere if all of us as a citizen or entrepreneur or whatever we are, we think about when we do something as an action.
So, Maurizio, Gr3n has been through a long journey, or rather a long journey until the recent fundraise, and which means there is a lot of work that has gone through your company and the way you approach this particular problem of having a closed loop recycling. So, can you give us the origins of Gr3n and how you were involved in this personally? From where did you conceptualize the idea, and how did you get here?
It started a long time ago. To be honest, in a party. During a party, someone came to me and said, "Hey, guess what? We have a problem recycling plastic trays because those are laminated materials. So in one side we have polyolefins, in the other side we have polyester, so PET. So we cannot recycle mechanically." And until that time, I was not working on recycling. I was doing something else. I was in university working on inorganic chemistry. Before I worked on organic chemistry and so on. So I came home and I thought about it to have the idea to depolymerize PET, recover it, the monomers, and then leave the polyethylene behind, suitable to be recycled. So the day after I went to university, I went in the lab and of my friends and I started to do some trials on the microwave he got in the lab, in his lab. And then after some trials and 1 week of studying, my friends came to me and said, okay, guess what? Now we're going to do this adventure together. And this is my business partner, one off.
Which year was this?
Oh, this was 2011.
Well, very long way.
Yeah, it's a long way. You think about it that we started from scratch in a time that when the pollution from plastics was not an issue for years, but because the perception of the pollution of plastics started 5 years ago, more or less. Before, nobody thought there was a problem.
Correct.
So for many years, we worked behind the scene. And later on, we got 2 European projects, one after the other one. So the European Commission, means the governments of Europe, believed on this idea and they thought that there was a problem. And so we started this adventure.
Well, for all the listeners who don't have a technical background, so what you're saying is the technology that you have is kind of better in a way that it breaks down the polymer. So plastic is basically a polymer composed of other minor particles called the monomers. So you have a technology that does this better. So am I correct in that?
Yeah, it's correct. A polymer, it means many repetitive units. The repetitive units are monomers. And all these big molecules are like chains, which are entangled each other. And in the middle of these chains, in the folding of these chains, are the colorants and the contaminants in general. So in the moment we cut the chains and we recover the building blocks, we free the colorants and the additives. So we retrieve pure building blocks that we can put together again and we produce virgin like polymer.
Well, when you started this in 2011-12, I don't think even European Union had the ban on single-use plastic, and not many countries in the world had this ban or any targets to ban single-use plastic. So how did you come up with the vision of your company, the vision around circularity of you need to close the loop from a monomer to polymer back to a monomer and close this loop? How did you come up with this vision and when was this?
Well, I got to this vision simply watching nature.
Wonderful.
Because I got inspiration from nature. Because when you see the fact that with the chlorophyll synthesis, the trees they take the CO2 using solar energy, and they transform CO2 in sugars that are used for building the structure of the tree itself. And then when these sugars are metabolized and then new CO2 is produced, this CO2 is again fixed with solar energy by other trees.
Correct.
So if you take advantage of energy, and in this case is solar energy, you can keep the carbon in a loop. This was the beginning of the idea. So we created a process which is energy dependent. It means that we recycle internally also the chemicals that we need for the process itself. So we have an internal loop. We don't have effluents, despite the contaminants, and we don't need chemicals. So we use only energy. So ideally, we could use solar energy or wind energy and doing everything, like the trees.
That's a good way to look at it because that clearly reminds me of having to look at nature for inspiration. And that's how a lot of products have come up and a lot of innovation has come up in that front. So that looks like the perfect USP that you need to have just a source of energy and then you allow the system to kind of do the process of circular conversion. So is that the only USP of the Demeto process or what are the other differentials compared to the current industry process?
First of all, there are different ways to break down polymeric chains.
Okay.
You can use different reaction. You can use glycolysis, methanolysis, or hydrolysis. We use hydrolysis. There are other companies doing our competitors. We know each other. Everyone is doing an amazing job. We are not to forget that I'm a scientist. So of course I respect the work of people because everybody is working very strongly to get the results. And personally, we decided, Matteo and I, to take this kind of reaction because we knew that it's easy to purify the monomers, so we could tackle the main problem, means contaminated polyester, which is textile. This is the reason why we choose this kind of technology instead of the other ones, because the monomers are easy to purify.
That's interesting. So textiles have a lot of contamination in them. So you feel your process helps them remove the contamination in the monomers. That's very interesting. But is it financially viable compared to the alternate process, or what are your views on that?
Our process is viable, commercially viable, economically viable, environmentally viable. Of course, I cannot compare with the process of my competitor because I don't know the details of the other competitors. I don't have their numbers, of course. Those are the private numbers. I know my numbers, evidently.
But when you pitch your technology, I know you're a scientist. So, but when your team or someone pitches the technology to the existing industry, you do have a product in terms of the technology. But how does the other pieces fit into the puzzle in terms of the existing value chain? How does this fit into that? What are the modifications that an existing company has to do that, or do you offer a end-to-end solution?
Our process really fits in the current value chain.
Okay.
Means that the product of green process are ethylene glycol and terephthalic acid, which are the ingredient needed to produce polyester, and these are the ingredients that typically the industry take from oil refinery. But it are the same molecules, so we integrate perfectly with the existing polymerization technologies present on the market.
Okay. But what are the other aspects to it? I understand that you have a project that is coming up, but how do you plan to scale it up in other markets? Is it really easy to set it up in other markets outside of Europe, in other emerging countries as well? What's your view on that?
No, you can really realize everywhere in the world. Of course, you need just to buy the technology from us in case, because we own the technology. But it's really scalable. It's not a big deal to scale it.
That's interesting. Currently, I understand there are two main markets that you look is one is the plastic, mostly the plastic, you kind of repurpose it and get it back to plastic bottles. And the other one is textiles where you get the polymers to kind of get to monomers and then provide it as raw materials to other industries. Am I correct?
No, effectively, we take the textile polyester and PET bottles are the same material. The textile is more contaminated because it's more colorful. Evidently, we don't dress with bottles which are transparent.
Okay.
But we need something to cover us. So there are other chemicals which count for 3, 4, 5%, not so much. The rest is polyester. Through our process, we can do what is called upcycling. It means that we take textile and we can produce a new bottle, not only a new textile. So effectively, mechanical recycling now take the bottles and produce yarns because the technical request of yarn is lower than bottles.
Fair.
So from bottles, you can do yarn. And what happens in the past decade is that PET is the most recycled plastics because the yarn industry absorbed the recycled polyester from the packaging industry. But now it's time to go the opposite. Take the textile and do new textile and new packaging.
That's really wonderful. And going back to the previous question, the reason I kind of asked that was because when I look into your platform, I'll have to bring your attention to that you have a platform where you tell anyone who wants to set up this recycling value chain, who has waste that they need to process, can register on your platform. And then you kind of, as you said, even if they are not able to sort the waste, you are taking it up and then you are upcycling it to products. So tell us more about the platform. How did this idea come about?
Okay, the platform is a P-term, and the idea came looking the market, especially in Europe, which is a good market where the packaging is collected and sorted systematically because the system. But when we think about textile, the logistic to collect the textile is completely missed
Correct.
everywhere in the globe.
Correct.
But there are a lot of waste, for example, from industry waste, which are currently burned.
Correct.
Or landfill. Where's the landfill? So the idea was, okay, let's try to map where these materials are. Because we need to understand because we know there is a lot of material. Consider that the 2/3 of polyester produced globally is used for textile, not for packaging. So the idea said, okay, we have a lot of material. Where is this material? We know that it's fractionated. We have to go, we knock the door about 100 people every day. So it's going to be a nightmare. Why we do not invite these people to sign up in our platform and say, okay, I have this polyester material with this kind of contaminant. This is the place this is more or less the amount per year we have. And then later on, after the mapping is almost close or in a good state of advance, we're going to start to talk and talk each other to create a one-to-one relationship to think about how we can retrieve this material to our facility to be processed. So P-turn is a long journey. Now we are in a mapping phase, and then later on we will start to do this connection, and then later on we will have the material, we will bring the material to our facility, and we will transform in virgin polyester.
Oh, that's interesting. So this also brings me to my next question. So we do have this about upcycling. You do recycle the products and upcycle to PET bottles. So what's next on the horizon? Can this technology be used to recycle and get other products as well?
Well, if the materials, the products are done in polyester, yes.
Okay.
If we talk about other polymers, we need to do other reaction. The reaction condition for the polyester are not applicable to, for example, polyamides or polycarbonate or polyethylene, polyolefin. So some kind of material can be processed similarly. Some other materials, they need a pyrolysis reaction.
Okay.
Like polyolefins, for example. So it's a different polymer, different technology.
That's really wonderful. Maurizio, on the next note, what are your plans for the future now that recently you did have a big funding round? Big companies, big corporates are now backing you up in the Series B. So what's next for the company and where do you plan to take it forward?
Well, there will be a round B in the near future because now we are preparing to go commercially to realize the first commercial plan based on our technology. So then we start the true commercialization. This is the closest future I can see. Later on, we will see.
Well, that's really good because I'm sure with a lot of money coming in, the technology research and everything else can be.
For sure, what I can say.
Yeah.
For sure, what I can say is that when you do industrial chemistry, monies are always welcome. That's for sure.
That's wonderful. And if I may ask, is that the sector to be in when you have to attract money? Because I talk to a lot of entrepreneurs, clean tech entrepreneurs, but a lot of them do admit that it is hard to convince investors. Do you think that this is a space that they need to focus on?
Well, we are now experiencing a huge momentum for recycling and clean tech in general. Until 5 years ago, was really hard to convince investors to put some money on. Now, the wind changed, and there is a lot of requests to invest in these technologies. We receive requests every day, practically, to jump in.
That's really a nice place to be in, especially when people know that you just closed a round, but they are still interested to invest in the next one. That means there is a definite demand for this product. So that's wonderful. Now, I will ask you to remove your hat of a founder and then shift focus and answer this question as a common man. You are solving one of the biggest problems of plastic. What would your suggestion or tip be to general consumers or general listeners to the podcast if they have to switch their lifestyle, live a sustainable lifestyle?
It's what I do in my life, to be honest, not as a CEO of Gr3n. But what I can say is that every time as a consumer or as a living being we do, every action we take every day, we have to think about the consequences of our action on the environment and on this world. This is the main point. For example, we know that eating meat is very demanding in terms of resources for the earth. So why we don't try to eat good meat, but few times a week? This is a good idea, for example.
Correct.
Or why let's pay attention about what we purchase and to avoid wasting food. This is one of the big problems. When I hear people around saying, "Oh, we don't need packaging," so pay attention, because packaging as a function is protecting food and avoiding waste of food.
Correct.
And wasting food is one of the big problems, especially when the world population is going to target 10 billion people. So food is going to be a problem. So every action has to be devoted to save it.
Well, that's really wonderful. And coming from the mouth of a CEO whose entire business and technology depends on solving problems, you're actually giving a valuable suggestion that, hey, we don't have to create new problems. We already have enough problems for which we are trying to find solutions. So that's really wonderful. Maurizio, it's been an absolute pleasure to have you on the podcast, and you were really candid with whatever you spoke about. So thanks for taking time and joining me on the podcast. And I'm sure a lot of listeners will kind of take your words and probably change their approach a little bit, and it'll make a big difference in the long run.
Thank you very much for giving me the occasion to speak at your podcast. Thank you. It was a very pleasure.
And that was a wrap on yet another insightful conversation. All technology companies that are into recycling have found it very hard to source good quality waste. And Gr3n, that is Gr3n, is also no different. And hence they have launched their own platform, P-Turn. The goal is also to avoid incineration and dumping into landfills. This way, large textile industries might find it useful to get into the system and streamline their processes. Because, as Maurizio mentioned, every polymer has a different technology requirement to break it down and then upcycle. The other big piece of information was all about investments, which is coming up in big numbers, especially in clean tech and in this case even waste management. And I have been posting about it regularly on my social media handles. Again, it comes up on the Mission Shunya feed across Twitter and Facebook. So do follow Mission Shunya across social media channels. And you should definitely follow Gr3n and Maurizio. I will drop the links to connect in the show notes section as usual. And if you haven't spread the message about the podcast to a wider audience, please consider doing that now. It'll go a long way in the show's discoverability. I will be back in 2 weeks' time with yet another insightful conversation on this podcast platform. So subscribe to this. And with that, this is Girish Shivakumar signing off. And as always, thank you for listening.